In this video, we're going to cover circuit diagrams. Circuit diagrams consist of shorthand symbols that are used to describe different electrical components. So drawing realistic pictures of circuits can be very difficult, and so for this reason we come up with these simplified symbols. So again, we've already covered resistor, so there you can see a resistor. The battery has a long terminal and a short terminal. The long terminal represents the plus side of the battery. The small terminal that you see right here represents the, here, let me put it here. This is your plus terminal, and this is your minus terminal. Okay? And then any conducting wire is going to be just a straight line. So circuit diagrams do not show where you put each part of it physically. Okay, so where you physically have a battery or a wire or a resistor is not what a circuit diagram does. Okay, so to draw a simple circuit diagram that has a 9-volt battery with a 3-ohm resistor across its terminals, we need to determine what the magnitude and direction of the current is going to be. So the first thing we want to do is we want to draw our circuit where we have our battery right here, okay, and our resistor right here. So here's our resistor, here's our battery. Again, this is the plus terminal and the minus terminal, okay, and the current flows from the positive terminal this way around the circuit, okay. And in order to determine what that current is, we're going to use Ohm's law. So now, some people may say to you, well, the current flows from the negative to the positive terminal. And that really is true. The electrons themselves actually move from the negative terminal to the positive terminal because the electrons are what moves. But when Benjamin Franklin discovered electricity, they thought that the positive charges were what moved. Okay, and so for years they had defined the direction of the current being from positive to the negative. Okay, we know now that the electrons are what moves, but it's okay because as the electrons move from the negative terminal to the positive, it effectively looks like the positives are moving from the positive to the negative. Okay, don't worry about that. Just know that for conventional current, we always make the electrons move from the plus terminal to the minus terminal, even though they physically go in the opposite direction. Okay, so how do we find the current? Current is equal to V over R, which is going to be our 9 volts divided by our 3 ohms, and that's going to give us 3 amperes. Okay, there are 2 ways to add a second resistor to a circuit. We can either add them in series, which you see right here on the left, series, or we can add them in parallel, which you see on the right-hand side. Notice the difference. And what I'm going to do is this. I'm going to show you a little something. If I have the current moving from the plus terminal around this circuit, what happens? It just keeps going, doesn't it? Okay, the current just keeps moving. All those electrons have to move around the same way. And that means that all the charges must move through both resistors to get to the negative terminal. Okay, now look at the parallel circuit. Now what I'm going to do is I'm going to draw my electrons moving around. And here we go. Uh-oh, what happens here? We got a bust, man. Okay, so some of the electrons are going to move this way. Okay, and some of the electrons are going to move this way. But guess what? They're all going to meet up at this. This is called a junction. Okay, this is called a junction. And the electrons are going to meet up, and remember, charge is conserved. So what we start with here has to be what we end up with here. So all the electrons that go this way and all the electrons that go this way have to add up to give us the same number of electrons on the other side. Okay? So it's sort of like people. If I have 5 people go in through a door and 3 go into one line and 2 go into a different line, I'm still going to have 5 people coming out. Okay? Same thing with current. Whatever goes in must come out because charge is conserved. Okay, so here you see charges pass through either R1 or R2, but they don't go through both. They have to make a choice. Okay, so are the following sets of resistors in series or parallel? The easiest way to determine that is for you to draw your current path. So go ahead and take your finger and go from the plus terminal of the battery to the negative terminal of the battery and see, without lifting your finger, if you can make it from one terminal to the other by going through both resistors. Okay, hopefully what you found was that the circuit on the right here is in series, and the one here is in parallel. And how do I know this one's in parallel? Right here's a junction. I had to make a choice. Was I going to keep going like this, or was I going to go like this? Okay, so I had to make a choice when I came up to this junction. Which way was I going to go? So again, this one's in parallel on the left, the one on the right is series. The test is to trace the shortest route around the circuit. The resistors found on the same route are in series. Those not found on the same route are in parallel. That's really important when we get into combination circuits. So please make sure that if you're not going to remember this after 5 seconds after watching the video, that you go ahead and write this on the note card and keep reading over it. Okay, so now we're going to talk about equivalent resistance. Resistors and voltage from batteries determine the current. Circuits can be redrawn as if there were only one resistor and battery. By reducing the circuit this way, the circuit becomes easier to study. Okay, this process is called reducing the circuit and giving us an equivalent resistance. Okay, so what we're going to do is this circuit here has 2 resistors, and we want to replace those 2 resistors with 1 resistor. So how are we going to do that? Okay, so when you're working with a series circuit, let's look at how we determine the equivalent resistance. What happens to the current in the circuit? Does it split off, or does it go through both resistors? That's right. The current passes through both of the resistors. So that makes this a series circuit. What happens to the voltage as it moves around the circuit? Now, this is a little different. The sum of the voltage drops across each of the resistors in a series circuit is equal to the voltage of the battery. That means that this is going to have a voltage of V1, and this is going to have a voltage of V2, even though this has a current of I, and this has a current of I. And that makes sense because I is equal to V over R. So if I keep I the same and I change R, V also has to change. Okay, so in a series circuit, if V, the total voltage of the battery, is equal to V1 plus V2 plus V3, and we substitute in V equals IR from Ohm's law into that equation, we end up with V being equal to IR, V1 is equal to I1R1, V2 is equal to I2R2, V3 is equal to I3R3, and so on. Okay? But we know that I is the same for every single one of the resistors, right? The total current is the same throughout the whole circuit. So we can replace I1, I2, I3 with I. So now we have IR1, or IR1, IR2, IR3. Now, if we divide both sides by divide both sides by I, what do we end up with? R equivalent is equal to R1 plus R2 plus R3. Okay, so memorize this. It'll be on your formula sheet for your AP exam. Okay? For a series circuit, the total resistance of the circuit is the sum of all the resistors. Okay, so now for a parallel circuit, let's find the equivalent resistance. So what happens to the current in a circuit that's in parallel? That's right. The sum of the currents through each of the resistor in a parallel circuit is equal to the current of the battery. I is the current coming out of the battery, and I1 and I2 are the currents going through R1 and R2, respectively. Okay, so look at the drawing here. Okay, remember we have I coming out. Where's my marker? There we go. We have I coming out. It splits here. We're going to have I1 going through R1. And we're going to have I2 going through R2. Okay? And remember I said the sum of the currents through each of the resistors has to equal the total current. So when I get back over to here to this junction, I'm going to have I coming out. And that means that I is going to be equal to I1 plus I2. And you'll have to excuse my writing. I'm using a mouse. Okay. I is the current coming out of the battery. I1 and I2 are the currents going through R1 and R2 respectively. And that means that I is equal to I1 plus I2. Okay, so what happens to the voltage as it moves across the circuit? Well, because the potential drop here, because the potential drop here and here is the same as here and here, that means that the voltage drop from here to here has to be the same as from here to here, which is the same as from here to here, which means the voltage drop for R1 has to be equal to the voltage drop for R2, which has to equal the voltage of the battery. Okay? So the voltage across all of the resistors in a parallel circuit is the same. V is the voltage supplied by the battery. V1 and V2 are the voltage drops on R1 and R2. But V, the total voltage of the battery, is equal to V1, which is equal to V2. Okay, so if we rewrite Ohm's law, we can substitute into this equation I, which is equal to V over R. Okay, so substituting that in from that equation to here, we get this. Now remember that the V's are all the same. So we're going to replace the V1, the V2, and the V3 with V. Okay? Now, we can take one of those V's out, okay? And then we can divide both sides by V. So if we divide by V here and divide by V here, because you got to do it on both sides or it's not equal, you end up with this equation, okay? So the equivalent resistance of a parallel circuit is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and then you have to take the inverse of the whole thing, okay? So what I'm going to do is I'm going to extend this up. So R equivalent is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3, all to the negative 1 power. Now I'm going to show you a trick on your calculator. What I want you to do is look for the x to the negative 1 button, and you're going to use that instead of taking 1 divided by r. Okay? So if you take R1 and then hit that x to the negative 1 button on your calculator, It'll make it so much easier. And then when you hit enter here, right here, when you hit enter, then you hit that inverse key again on your calculator and hit enter again, and it will give you the inverse of this whole sum. If you want to know what I mean, or if you have any questions about that, come see me at lunch. I can show you real quick. Okay, so the equivalent resistance is going to be 1 over the equivalent resistance equals 1 over R1 plus 1 over R2 plus 1 over R3. Adding more resistors will decrease the equivalent resistance of a parallel circuit. Okay? Conceptually, adding more resistors in parallel gives more paths for the electrons to flow. Hence, for a given electrical potential, more current will flow through a smaller resistance. So the more and more resistors you add in parallel, the higher and higher the current gets. Now this can be dangerous because if the current flow is high enough, it can heat the wires to the point where they melt. And then when they melt, they'll disconnect and then you have a short circuit. Okay, or an open circuit, sorry. You have an open circuit. Or it could melt and give you a short circuit. I'm not sure. If it depends on how close the wires are. Okay, so that could cause a fire. Okay, so this is why you have circuit breakers or fuses in your house and in your electronics. Okay, to keep your house from burning down. Okay, so here's a circuit diagram. Now this is called a combination circuit. Okay, so notice that we have the current going through, and I'm going to keep my current in purple. Okay, now I have to choose a path. So I can choose up here and come back down, and then I can choose this way and come back down. Notice how I use a different color for each one. This is another reason why I love colored pencils. Everyone says, Dr. H, why do you always use color? I can see this, right? Look at this. I can see that the current going through R2 is different than the current going through R1, which is different than the current going through R3, just by looking at the colors. And by looking at the colors, I know purple is equal to green plus blue, right? So green plus blue has to give me purple, because I start with purple and I end with purple. And I have green and blue in between. So this is perfect for being able to figure out whether you have resistors in series or parallel. Okay, so the first thing you want to do is you want to add the two resistors in parallel first. So we would take 1 over 3 plus 1 over 6, and that is equal to, if we come up with a common denominator, we end up with, let's see, I believe that would be 18. And that is going to give me 9 ohms over 18 ohms. And then what I'm going to do is I'm going to flip that, because this is 1 over R equivalent. So R equivalent is going to be equal to 18 ohms, sorry, that's not an ohm, over 9. And that gives me an equivalent resistance of 2 ohms. Okay, did I get that right? Let's check. Yes. 1 over 6 plus 1 over 3 equals 1 over 2. And then when you flip that, it gives you 2 ohms. Okay, now what I'm going to do is I'm going to redraw this circuit with that new resistor. Okay? See, I've found the resistance here. I'm going to redraw this now. Okay? So now I have one resistor, and then the battery. Okay? I'm going to call this 2 ohms. And what was the previous one? 4 ohms. Okay, now I'm going to draw my current again. Notice that my current goes through both of the resistors the same amount. That means that these two resistors are in series. So that means I can add them together. So I have my equivalent resistance here is going to be equal to 2 ohms plus 4 ohms, and that's equal to, I'm sorry, I'm multiplying. Let me erase. Where's my eraser? Okay. And that's going to give me 6 ohms. Okay, so my total resistance of the circuit is going to be 6 ohms. And that's what they get here. Okay, they do some steps all together. I don't like doing that. Okay, now, what I effectively have now is a circuit that has one resistor that is 6 ohms, and the battery is an 18-volt battery. Now, in order to find the current is equal to V over R, which is going to be 18 volts divided by 6 ohms, and that means the current is going to be 3 amps. Okay? And there you get it, 3 amps. Okay, now let's find the voltage on the next 2 resistors. Let's go back up. Okay, so here's the thing. What stays the same in a series circuit, the current or the voltage on the resistors? Hopefully you said current. Thank you. Okay, so the current is going to stay the same. So that means that my current here is going to be 3 amps, and this is going to be 3 amps. Okay? Now let's find the voltage. Let's make the voltage a different color. Let's make it, I don't know, let's do that color. I don't know what color that is, but that's what we're going to do. Okay, so my voltage for the 2 ohm resistor is going to be equal to IR, which is going to be 2 ohms times 3 amps. Sorry, I'm writing my my mouse thing, my finger. And 2 times 3 is 6, so that gives us 6 volts. So this is 6 volts. Okay, for the other one, it's going to be V for the 4 ohm resistor. 4 ohm resistor, and that's going to be 4 ohms times 3 amps, and that's going to give me 12 volts. Okay, so this is 12 volts here, 12 volts. Okay, so now you can see that this is going to be 12 volts. Okay, and that both of these are going to have a voltage of 6 volts. 6 volts here, 6 volts here. And now, if I were to ask you, looking at R1, you have the voltage and you have the resistance. Can you calculate the current using Ohm's law? You may be saying, no, Dr. H, I don't know what the hell you just did. It's okay. I'm sorry I cussed, but that's probably what you're thinking. Or maybe you're thinking, I need to get a tissue because I'm going to cry myself to sleep because I don't understand this. That's okay. Just play the video in slow motion, okay, and go through it again. If I ask you to solve for the current, we know that the current is equal to V over R. 6 divided by 3 gives me 2 amps, right? 6 divided by 6 gives me 1 amp. Okay, now let's make sure that all of our voltages are the right voltage. What's 6 plus 12? 18, that's right. And what is our power supply? 18, that's right. Okay, so there you go. That's how you solve this problem. What you may want to do is go in slow motion because I get very excited about these circuits. So what you may want to do is just play it back in slow motion. Okay, in the next video, we're going to cover measurement.